Okay, Assalamualaikum. So basically for this week the tutorial I will show you one by one because we don't have any live class. Okay, so you may download the tutorial inside your Microsoft Teams and try to do based on what I shows the calculations involved for each question. Okay, so the first question is about several linear transmitters have been installed and calibrated. So we have flow rate, pressure and level. So what we need to do is we need to calculate the gain for each transmitter and also develop an expression. Okay, given in here is the signal, pneumatic transmitter. For the flow rate, we have current transmitter for the pressure, and we have a voltage transmitter for the level. Okay, for the pneumatic transmitter, okay, basically we can calculate the gain is equal to range of the output, which is in the PSIG, divided with range of input, which is in gallon per minute. Okay, so we take the value, the bigger value should minus the lower value. 15 minus 3 and 100 minus 0. Okay, so for this one we will get the answer of 12 over, sorry, this one is 400. The last answer would be 0.03 PSIG over gallon per minute. Okay, so this is for the first flow rate. Okay, for the second one, which is for pressure, okay, we have this part is an input, this part is output. Okay, from the pressure is in pressure unit in Hg, to convert to current transmitter, which is in milliampere. Okay, so to calculate the gain, we need to divide the range of output over range of input, which is 20 minus 4 over with 30 minus 10. So this one we will get 0.8 milliampere over in inch Hg. Okay, for the level, so basically the input, so this is basically the input for the transmitter. That's mean the value that we measure for your process variable. So the input is in meter, it's related to the level. For example, for the pressure, is the unit is inch Hg, is related to the pressure. This one also is related, gallon per minute is related to the flow rate. Okay, so for the level, to calculate the transmitter gain, output over input, which is 5. So for the level, the current the transmitter being used is voltage transmitter. 5 minus 1 over 20 minus 0.5. So this one you will get 0.205 voltage over meter. Okay, so this is for question number 1. So the second question, you need to develop an expression for the output of each transmitter as a function of its input. So basically, if we want to write the functions, normally we will use the equation y equal to mx plus c. So this equation basically shows the function, the output, and this is the output y as a function of its input, which is x. Okay, so let's try to do one by one. Okay, we have 3, which is flow, pressure and level. So question number 2, we start with flow rate. So we need to use y equal to mx plus c. So the input, okay, y would be the output. So basically this one output, this one input. So the output will be 15. The value of m is basically the gradient of the graph. So the gradient basically is a gain. So this one is the gain. So we left first the we didn't key in first the value of m. So we change the value of x to the input is 400. So this one would be 400 plus c. Okay, so we have two unknown here, which is m and c. Okay, but when we refer to previous question, okay, we already calculate the gain. So basically the gain is the range of output over range of input. So that one basically is shows that the gain basically is the gradient of the graph. So we can take the value of the gain to key in inside the m value, which is 0.03 400 plus c. So we can solve c. So c would be equal to 3. So the last equation, okay, y equal to m, our gain 0.03x plus with 3. So for the flow rate, this is the expression of the output as a function of input. Okay, we have second type. Okay, the second type is pressure. Okay, so same, we use y equal to mx plus c. So for the output first, the y, which is 20 milliampere. So we change it as a, we insert the value into y. The value of m is a gain, but we left it first. X, the input would be 30 plus c. So now we insert the gain value, which is 0.8. We need to solve for c. So the c value would be -4. So the last expression is y equal to 0.8x minus 4. So this is for the pressure. Okay, now we go to the level. So level, same equation need to use mx plus c. So y for the level is 5, x for the level is 20. So 5 m 20 plus c. So the value of m is 0.205. So we can solve. The value of c. C is equal to 0.9. Rewrite the expression y is equal to the value of gradient or the gain 0.205 x plus 0.9 So this is the expression for the level. Okay, so we finish on the question 1. So now we go to the question number 2. Okay, let's read the question first and take out the important information inside the question. Okay, so we can see here an operator was told to control temperature at reactor 60 degrees Celsius. The operator set the set point at 60%. So the scale actually indicates 0 to 100% of a temperature range 0 to 200 degrees Celsius. So this caused a runaway reaction that overpressurized the vessel. A liquid was discharged and injured the operator. What was the set point temperature the operator actually set? So basically this is the value of the set point, 60%. So okay, we can construct a table which is the percentage is from 0 to 100%. Okay, the operator set the set point 60%. So you know that the zero range is 0, the upper range is 200 degrees Celsius. So the value of X is the set point that been set by the operator. So we can use the interpolations formula, which is (60 minus 0 over X minus 0 is equal to 100 minus 0 over 200 minus 0. So try to solve this and you will get X equal to 120 degrees Celsius. So this is the value of set point in terms of temperature. So in terms of percentage is 60%. Okay, finish on question number 2. Now we want to solve for question number 3, which is find the gain of pneumatic to current transducer. The gain. So basically the gain, the formula of the gain is, again, range of output over range of input. Okay, so basically pneumatic transducer is operate from 3 to 15 psig. So the current signal is from 4 to 20 milliampere. So the input would be, inside the question mentioned that the gain of pneumatic to current transducer. That means this is the input, this is the output. So you may calculate like this: 20 minus 40 over 15 minus 3. So the final answer would be 1.33 milliampere over psi. Okay, so finish on the tutorial. So I hope you can try to solve all of these questions and try to do on your own. If you don't understand on either question 1, 2 or 3, you can directly asking to me. Okay, thank you.